Well, good evening. It's November 9th. Been a while since we've done a star party. I thought I would try to capture some planets tonight. We're running out of really nice weather, and it's a nice evening tonight. It's fairly warm out, and it was also very clear, good transparency. So I thought we might try a little more of the planets. So I'm here at the Ferris Center, and I'm actually on Mars. Took me a little while to get there, even though I need to correct this. It took me a while to get there and focus. So actually, well, you can watch me. I'm going to synchronize the telescope to make sure that it knows where it's at. Yep, we are on Mars, and so we are synchronized. This is the sky X. Looks like Mars is right in the middle of Pisces. Very pretty constellation. Got a little head of a fish here, and then a line, another line, and another fish over there. So this is Pisces. Right next door is Aries, the ram, a big horn of Aries. So that's where Mars is tonight. And I hope that we'll look at, we'll try to look at Neptune and Uranus as well. And I see Neptune is very near the meridian, so I may want to try to get Neptune video pretty quickly before I get over the other side of the meridian. But right now I'm on Mars, and I'll flip over to what I'm capturing right now. I'm capturing 10,000 frames of Mars, and I'll show you what I'm doing here. If I can get my software to cooperate, you might hear me clicking around here. I'm going to switch over to the other capture window. What am I doing? Okay. I have to hide this one maybe? Yep, there we go. So now we're on the other capture frame, and this is what the camera, the ZWO ASI 294 is capturing right now. This is video, and you can see it kind of blurs in and out. It kind of moves around a little bit, and with video, as opposed to just taking images, you can get lots and lots of individual images through video. And if you use a program called Auto Stackert, it's just a godsend for planetary imaging. What that can do is sort all these images out, these 10,000 images, and then it'll rate them and rank them. And you could take the top 50%, whatever number you like, 10%, 5%, and stack just those, align them, stack them, and come out with some pretty nice images. And if you saw a couple of images I put on Facebook, I sent some out to the club, and you've seen what Kevin Lyons has done. He uses a similar method, although he's a little more experienced at using it than I am. And that's what he'll use to stack these images. And pretty amazing what you can do with video. So we're going to stay on this for a little bit. I'm going to get 10,000 images, and then I'll save them, stack them, and then at the after through some post-processing, you'll see what you can see what I get developed on that for this Mars image. So let's see where I'm at here. I'm at I got a long way to go. I've only got about 400 images done, so it's going to take a while for this to collect. And if it takes too long, I may interrupt it and just do a shorter batch of images. So more to come. I will pause you guys and come back when I got more to talk about. So we're finishing up a Mars run here. I've got about the 1200 frame video. I got another 3-minute video. I'm about to finish up another 3-minute video of Mars, and so I'll take some time to analyze them, stack them, and see what kind of images I can get out of Mars. This one's going to finish in a couple of seconds here. And then when it does, you can see we're at about 95%. Then we'll go back to our map, our software, our astronomy software, the sky. Looks like we're done. Okay, so here is the image of Mars I was able to get using, so captured with ASI cap. I got video, and I took that video in auto stackered and stacked. I think I only got about 3,000 images in the video. I stacked the top 26% was going to give me a good image. I stacked that up, and then I took the resulting image, put that into Registax, and then used the wavelet function on there to really sharpen up the details. And you can see I got some really nice sharpness out of the image. You saw the movie image live as it was capturing video, and now you can see it all sharpened up with all the best images all piled up. And with wavelets, I'm able to really get some nice sharp edges to that big dark prominent feature is called Syrtis Major. You can see the polar ice cap down at about 4 o'clock, 5 o'clock. The southern polar ice cap. And other details in there, I could probably draw lines and point them out, but no need to do that. Just glad to get a nice clear image of Mars this late in the year. It'll start to get colder, it'll start to get less visibility, and Mars is already moving away at a very fast clip. It's already over 45 million miles away, so it's about 10 million miles. Well, it's at least 5 or 6 million miles further than it was when we were looking at this over the summer. So, farewell to Mars, and a nice tribute in this image. Enjoy. So we're going to go back to the sky, and right over here is Uranus. It's not too far a hop. It's on the ecliptic. I'm hoping I can find it pretty quickly. Alright, at least find it with the telescope, I mean. So I'm going to, let's see, I'm going to shrink this down a bit so you can see both of these. Okay, we'll leave that on. I think you can see everything I'm seeing here, and you can kind of see where I'm going to slew to. Let me spread this open a little more. We're going to slide along the ecliptic here, and hopefully we will land. Oh, I'm looking the wrong way here. This way. There's Uranus, there's Mars. We will slew to Uranus. Yes, I want to slew to Uranus. Here we go. And with any luck, now Uranus is dimmer, so I'm going to pump the gain all the way up, get a longer exposure. See what I got here. It doesn't look like I landed right on it, which is kind of what I expected. So, but what I can do is I will try live with you right now to try to find Uranus. When I had trouble with Mars, I found it was off a little bit in this direction. What have I got here? Oops. Got a couple stars. So, what I'm going to do is I'm going to pause you. I'm going to go up to the telescope and look through the finder scopes, see what I can see, try to find Uranus, zero in on it, and then we'll start taking video of that. So, I'll come back when I've found Uranus. You don't need to go through all this painstaking slewing to try to find it with me. I will make it easy. So I'll be back. Okay. I don't know if I ever stopped recording or not. Let me pause. Alright, so we're back. And I think I found Uranus. I used the finder scope to center it in the telescope. Here's the sky. I'll make the sky a little bigger. And let's see, we'll zoom. And it was actually pretty close. The scope was close. It wasn't right on. but it was better than it was acting the last time I was there. So I'm going to synchronize it. Yes, that's where we are. It wasn't off by too much. So that's pretty good. But that's good. So that looks like Uranus. What I can do now is I can adjust the exposure on it. I don't need this much gain. Let's back the gain back. I'd like to try to get no gain. Oops. Looks like no gain is no go. There it is. So, yeah, definitely planetary. You can see it's kind of a blue-green color. So I'm going to play with this. You can watch me do this live. Play with the gain and the exposure. I kind of like that. That's pretty good. I'll bump the exposure up a little bit. I didn't put a Barlow lens in it this time, and because I've had trouble trying to find where I'm at with the Barlow in it. Although I would get much better images, it would take me much longer to do so. So I'm zoomed all the way out now, so you can see that it's a really small object if you're looking at it. You're actually seeing two screens overlaying each other. You're seeing the sky on one part and the ASI cap, which is the capture tool I'm using this time. I think I used a different one last time, but that's definitely Uranus. And what I'm going to do is I'll take a little video of that. I don't know if I'll get much more detail out of it, but it's kind of cool to see this. We tried to find this at the last planetary star party, and we couldn't because it was in the trees, but it has since moved further along in the ecliptic as the season has moved forward. So you can see it's moving around quite a bit. I'm zoomed in a bunch, so this is it zoomed all the way out. That is the beauty of digital captures. You can play around with what you got. A tiny little thing here, tiny little Uranus, but I can zoom right in, and I could definitely see the blue-green color of Uranus. So, with the exposure the way it is, I think I'll try to do a video of it. Let's see, we'll do. We want 225 milliseconds and a gain of 264, and we'll take 3 minutes of video. I guess I was recording something. Well, we'll try it again. So I have a feeling I was recording something. But we'll try again. So we'll start here with 225, 264, 180 seconds is 3 minutes. Let's run this and see what we can get. I'll move this so you can see a little better. Or I'll switch the window. Let's get rid of that one. We'll just do that one. So that's what we're videoing. I'm zoomed in on it. And I can clean that up a little bit with Auto Stackert, and then maybe a little bit with Registax, clean it up. I don't expect to see much detail on Uranus being, let's see, Uranus is twice as far as Saturn, so it looks like it's over 1 billion miles away. That's a long ways away. I think it's like 1.8 billion miles. That's a long ways away. An ice giant. So about a third of the way through the capture. So it'll take 3 minutes of video. I might do a second or third video, and then I'll show you what I get after I develop it or play around with it, and we'll look at it next. I'll be back in a little while. Okay, so here's Uranus. First I'll show you the wide field. This is pretty much what hits the sensor. through a 14-inch telescope at f11. It's that tiny little dot right there in the middle. That's what the sensor's getting for Uranus. And it's an ice giant. There's not a lot of surface detail on it like there is on Mars and even Jupiter and Saturn. We can see some clouds, cloud decks, and some ring differences. These ice giants, both Uranus and Neptune, don't have a lot of detail. Plus, they're really far away. So that's what I've got. I'll merge into the zoomed shot I got, and no matter how much I tried to pull out detail in Registax with wavelets, whatever, that's all I got. And it seemed the more I did, the worse it looked. So that's a zoomed in Uranus. But what do you expect? It's 1.75 billion miles away. 1.75 billion miles away. I have to convert. It gives me AU when I look at my Sky software. So I have to convert it. It's 18.8 AU, which to me it's roughly. I mean, AU is roughly a little less than 100,000 miles. So you can kind of figure it that way. But 1.75 billion miles away. There's Uranus, all zoomed in. Enjoy that. Okay, so that's Uranus. Let's go back to the sky. Hang on. I'll make the sky visible. And we'll close that one. Make it a little bigger. And I got a feeling we're going to do a meridian flip. But we'll give it we will do a meridian flip. But I'll keep you here while I do it. And we'll talk about what we're headed to here. So we're going to go to find Neptune. Neptune, we're going to find it. It's across the meridian. Let's see what we do. I'm sure we're going to go all the way around. Yep, so we're going to go all the way around. And I'll bet you $1 we don't land right on it. But I'd be happy to pay $1 to land right on it. We're going to swing all the way around north. This is done so that the telescope doesn't wind wires and such all the way around. It's actually a safety measure. So that's a good idea for it to happen. And we're zooming in onto Neptune, or hopefully we're zooming into Neptune. It's very busy when you look at this sky chart, but once you get to know it, it's really not too bad. Got a nice little line here for the ecliptic, for the meridian, and a whole bunch of objects in different colors. All your NGC objects are in red. It looks like there's some in pink as well. So it looks like we're on Neptune, and we'll swing over to here. I'm going to increase the exposure and the gain way up and take a look. What do we got over here? Is this Neptune? Doesn't look it. That looks like a star. And some burned out pixels. Alright, so actually you're not seeing it. So what I did was I'll go back to this window here. So I'm looking at my hide that one. I'm looking in here to see if maybe way down here, if I zoom in, if that's Neptune, but it's not. That's a star. So what I'm going to do is I'm going to go up into the to the scope. Look at the finder scope. Last time I was around, I was right around Uranus, but not right on it. Hoping that I'm very similar to Neptune, and I can kind of zoom around. I might be able to see this star that's over in the corner of my image here, and then from there figure out where Neptune is. So I'll be back. Okay, so I flipped over the meridian. I went down to Neptune. I couldn't find it right away, so what I did was I went up I couldn't find it right away, so I went to a star just above Neptune, this Marcab. Here, part of constellation Marcab. I should know this. Oh, okay. So this is the great square of Pegasus, and the southwestern star is Marcab, and almost straight down was Neptune. It's almost you could almost use the one side of Pegasus to find Neptune. And so I found this, and I figured it was a short jog down to Neptune, and that's what I did. I found Marcab, centered it, told the telescope, hey, you're at Marcab, and then went down to Neptune and actually found it. So here's, let me get my my software is all squared away here, so I'm gonna hide that window and go to this one, and this is what I found. So this, I believe, is Neptune. So let me zoom in, and it looks like I have a moon. So that is pretty, maybe even a couple of moons. There's one here too. So let me zoom all the way in. It's way overexposed, but that's the only way I'm going to see the moons. I'm going to use some other software that you're not going to see if what I have here is Neptune. Let me see. If I used Starry Night, it may actually label the moons for me. I don't know that the sky does. So let me go to the sky. I'll go to the sky real quick, and we'll see if it tells me where the moons are. If I go all the way up to Neptune, zoom right in. Does it show me the moons? Oh, maybe. Maybe. Got something here. Really got to zoom. So that's Neptune. Nope, that's not a moon. That's Neptune. Yeah, might as well synchronize while I'm here. So go to telescope tab and synchronize on Neptune. Yes. Alright, so that's way very close. Alright, so it's not telling me in the sky what that moon is. So let me go back to the window capture here. And I want to know, if I'm looking at this, I want to know this, and it looks like there's another one out here. Those are moons. And what I will do, I will sharpen eventually, but I want to find out what those moons are. That's pretty cool to see. I'm starting up in another computer, Starry Night Pro, and I know that when I use that, it gives me the moons of the planets when they're showing. So as we wait for Starry Night Pro to start up, I'll pause, and we'll come back in a second. So consulting my Sky Safari, it would appear that this object here, you could see my cursor, this object here, zoom in, is Triton. And this one that's really close to, oh wait a minute, hang on. Hold on. Let me dim this up. If this is a star, then maybe that's Triton. Turn the gain way down. Yeah, so, harumph. Well, here's what I have. Either this or this is Triton. That's Neptune, and this is a little moon right here called Naiad or Galatia. Wow. Pretty cool. I know we got multiple moons here of Neptune. So now I'm going to try to get Neptune into it's overexposed, and that's the only way I can see these moons. So to overexpose them. So now I'm going to try to get the exposure down to what it should be to see the planet itself. So I'm turning the gain down a bit. Let's see, we'll leave the gain there, and maybe exposure a little bit less. 2 billion miles away, and we're looking at Neptune. That's pretty cool. So there's Neptune, kind of bouncing around there. So if I'm going to zoom all the way out, this is what we would look at, what we might see through a telescope, through probably like a 35 millimeter lens on this scope. It's just a blue dot. You can definitely tell that it's planetary. It's a blue dot, but when I zoom in, I'm able to figure out how much gain, how much exposure to put on it. I'll do a video of this. I don't expect to get much out of it. So I will do a, let's see, I'll set up a capture of it. If it, oops, stop that. I want to auto run. I want an exposure of 820 milliseconds with a gain of, oops, that's way too much. I put 8. With a gain of 311, and I'll run that exposure for 3 minutes. We'll take a 3-minute video of Neptune. Kind of cool that we got moons in there too. I might actually do a run with the moons, and maybe I can make a composite of the moons and Neptune together. So that would be kind of cool to see. Maybe you can see what I got. It's interesting because Triton's a pretty big moon. Triton, if I look it up, is about 1,353 kilometers in radius. And then my Sky Safari, the Sky, I don't even know the tool I'm using. It's Starry Night Pro is what I was using. I said Sky Safari. I can see 1, 2, 3, 4, 5 other moons, all really small. Naiad, the one I thought that this was, basically just by location, is 29 kilometers with a apparent magnitude of 24, so it's really dim. Thalassa is 37 kilometers with an apparent magnitude of 23.8. Galatia, which seems to be, yeah, I think it's Naiad. Galatia is a little further out, and I will show you the map. I'll superpose a picture of the map that I use. Galatia is 37.1 kilometers with a apparent magnitude of 22.31, which is a little bit brighter, but still, once your magnitude is over 20, it's really, really dim. And then Proteus has a radius of 37.1 kilometers with a apparent magnitude of 20. But looking at where Triton is, it looks like it's Naiad, because Naiad is right next to the planet, much like we saw in the prior exposure. So, but that's dim. I mean, it's 29 kilometers, it's 24.72 magnitude. That's a dim planet. Where Triton is, its apparent magnitude is 13.48, so it's fairly bright. So I'm thinking that Triton was that really bright one down to the bottom and the left, which would have made, let's see, it would have made it, the other one to the right would have been Proteus, and the one up on top would have been Larissa? Perhaps Larissa? Or Naiad. see here. There's another one. There's Nereid. Nereid is 170 kilometers and a magnitude 18.1. Interesting. So it's way out there. So maybe that we're looking at Triton is close. Nereid is way out. That's what we got. That's what we have. It's a much better diagnostic. Yeah, Triton is the close one, and the one that's way out is Nereid. Okay. So we'll do a video of that. Oh, this doesn't look good. It's all smearing all over the place here. It looks like that video's done. We'll do another one. We'll run another one real quick. So I have a couple to choose from. We'll do another 3-minute video, and then we'll try to do those moons again. That's pretty cool. Yeah, so the one that was real close was, I zoomed in too close, and there's other moons that are closer than Triton. But when I zoom out, and now the program gives me the Starry Night gives me the video or the names of the planets and the moons. Triton is the one that's close to Neptune, and one way out is Nereid, and we're seeing them reversed here from what I see on the screen. So pretty cool. Pretty cool. Triton is right up here, and way out there is Nereid. We'll after we run this last video, we're about 35% through the video we're recording. We'll look at it again. All right, we'll let that finish up, and then we'll take a look at the moons again. So we're just about done with recording Neptune. We are done now. And so what I'm going to do is I'm going to change the gain to try to pick up those moons again. So I've got one. This is Nereid. And then right next to Neptune, let me do too much gain. I'll take 2 seconds apart, maybe 3 seconds. All right. So out here we have Nereid. Over here we have Triton. But we have another one out here. Let me see if I can find what that is. That would, let's see. That's Triton. That's a star. Yep, that's a star. Yeah, so we got us, I'm sorry for the gap, but we got us a planet and 2 of its moons. I'm going to do a capture of this and do some more analysis. We'll do a video capture 3 seconds, that's a lot of gain. I wonder if I could pull the gain down just a tad. Nope. Need all that gain I could get to capture all that stuff. Okay. And let me see. I'm going to do a video of this, but I will do it. Let's see. Stop. Stop. I'm going to auto run. I'm going to do exposure is 3,000 milliseconds. Gain at 545. And we're just going to do 3 seconds. I'll do 2 minutes of that. I'll run it. Just to get a little data on those moons. So if that's opposite. Yeah, I think it's Nereid. This is Nereid. That's something else. It's just a star out there, at least according to the software. And that's Triton. And you know what? We are capturing. Well, maybe not. That just could be Neptune overexposed. Thought there might have been something there. There are moons in there, but they're so small that we're not capturing. They're not going to capture them with this camera. But the fact that we got Triton and Nereid is pretty cool. So yeah, we're about halfway through that capture, and we'll see what we get. I may get something I can composite with the moons and Neptune or not. Who knows? But we'll give it a shot. All right. Let's see what we get. So Neptune turned out to be pretty interesting this evening. Here is the wide shot of Neptune. If I had the gain set properly and looking for Neptune, this is the wide shot. Just that little blue dot. This is not enhanced at all, but that's the blue dot I captured without any further magnification. I didn't zoom in or anything. That's Neptune. And then I'll merge into a zoomed in, fully exposed Neptune. And you can see it is a beautiful blue planet without a lot of detail. I'm not able to get much detail out of it. I tried through Registax to pull some wavelet information out of it, and I'm just not, it's just too dim an object to get much, and I don't have enough detail or enough detail in the image captured to get more than just what I've got here. Now, next we'll look at the moons. Okay, so here is the image that I was able to get of the moons around Neptune. And what I did was I opened up my Sky Safari Pro and set it for the time that I took the image, froze it in time, and it started to look around what was there when I took the image. And I could see there that there's Neptune, and actually Triton was very close to Neptune, and Nereid was way out there. So then I rotated my image to match up with what I've got in Sky Safari and got this image. And if I look closer at that image, I can match up stars, moons, of particular brightness. So I was able to get the stars, particular stars in their brightness, if you can see that. And then the moons of Nereid and Triton. And so I thought I saw other little stuff near Neptune. And so here's a zoom in of Starry Night Pro getting close to Neptune and some of these tiny little moons around it, which I didn't think I could capture. They're so small, but I may have. Pretty sure I captured Proteus. And There's another moon there. It doesn't line up exactly right. It could be Galatia, it could be another moon. But in the end, I think we got at least 3 moons of Neptune, possibly 4. And all with a little 14-inch telescope here in Ionia, New York. I'm pretty pleased with the performance of this, getting these moons of Jupiter. And I wouldn't have even noticed them if I hadn't overexposed Neptune to begin with to see Triton and then compared to the software. But enjoy. That's a nice picture right here in Ionia, New York of Neptune and at least 3 of the 14 known moons of Neptune. Really enjoyed getting that tonight. Well, we've got a little extra time tonight, and since we're in this part of the sky, let's see what else we might find. M15 is nearby, a beautiful globular cluster in Pegasus, so let's take a look at that next. Well, we've got a little extra time tonight, and since we're in this part of the sky, let's see what else we might find. M15 is nearby, a beautiful globular cluster in Pegasus, so let's take a look at that next. So we're over at M15. I'm setting up with the different software and doing a capture. Let me see. I want to capture. It's been a while since I used this one. Preview. We'll do continuous. 2-minute images. All right, so we're on M15, and I'll show you the other, not that one. Let's see. Close this one. You've got all the garbage here. Hang on. Let's see. We want you to see this on the front. We got a few seconds left, so I'll be back momentarily. Yeah, so we captured a terrible image of M15. We can definitely see that it's a globular cluster, but it's definitely moved around in the 2 minutes that I took an image of it, and I'm cooling at the same time, so the cooling is changing. Here's another one. It's not tracking well. So this one's a 30-second image. You can see the trails in the image of where it's starting and going. It's a little better than the last one was, but definitely not tracking as good as it was for the planets earlier. Maybe it wasn't tracking that well before either. So another quick 30-second should be done in a couple of seconds. Let's see what that looks like. Boom, that's better. That's much better. Yeah, at first I thought it was focus, but that's a pretty good image. M15, a nice globular cluster. I'll give you some details on it when I look them up, so they'll be coming shortly. But M15, globular cluster up in the Pegasus, so kind of a bonus feature for tonight. Yeah, so moonrise isn't until 1 o'clock in the morning, and it's only 9:34. I got an early start because the planets were visible really early, and I don't know if I'm going to stay up that late, but we'll try a couple other little, maybe 1 or 2 other places to visit. Let's visit the double double. See if we can capture that. So here's let me see. Pull that off. Not that one. Not this one. And so the double double is over here by Vega. So right there. And let's see. STF 20. Yeah. That's not what I wanted to do. I want to go this one. Do that. Double, 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 double. With trouble. Okay. We'll slew over there. Yes. Let's see how we do. And we're there. Let's see what the software says. I guess I should do it. So continuous, 30 seconds. Okay. So we got a double image here. We got an M15 and the double double. You'll never see that in real life. Let me take a 30-second images here. So let it finish the next image. I'm going to short the next image. Let it finish this one. Okay, so I stopped that one. Both very bright. So maybe I need to turn the gain down. Shorten the exposure. And let's go now. Taking 5-second exposures and a low gain. So we've got closer to pinpoint stars. Let me move these over to the middle a little bit better. So in live time, you see the streaks across the screen here. It's taking a shot every 5 seconds. Let's see, going that way. Okay, that's not too bad. But I'm overexposed on the stars, so we're going to stop this. We're going to do an exposure of 1 second. Okay. Do high gain. Try it again. 1 second. Exposure. Yeah, so that helped a little bit. Pretty difficult to get that. You get a lot of noise when you crank that down much. So they're there. I can see a couple stars there. Let me drop the gain back and stop this. Drop the gain back to the middle. And maybe we'll do it as 2/10. Yeah, so if you can use your averted imagination here, you kind of see these two stars are oriented this way. These two stars are oriented this way. You can actually separate those two. I wonder if I can get better. It's a lot of noise. A really fast image. Let's see what that does. Yeah, pretty much eliminates it. Let's still see it at all. Yep, they're too bright, too close together to image. We tried this once before at another star party, but not easy to split them. So you got a pair that goes this way here and a pair that goes this way over there. But they're definitely not easy to separate. All right. Well, I can't resist one more place. Figure we're up here in Pegasus. We were down in the Double Double. I went back to Pegasus because I remembered there was a pretty galaxy in Pegasus we haven't looked at, and it's called the Little Sombrero. The big sombrero is M104. The little sombrero is an NGC object, NGC 7814, and it's over here near this corner of Pegasus called Algenib. So we're going to zoom, salute the camera over there, and we're going to take images of the little sombrero. So let's see what we got here. And we got a nice image. Here's a nice little dust lane. It's got a lot of high, a lot of noise because I had the gain up high. I'm doing another image now. Should be ready in a couple of seconds here with a low gain. Hopefully we get a little more detail in this galaxy, but it is a pretty galaxy. You got a nice long dust lane across it with a big bulge in the middle, giving it, excuse me, that sombrero look. And with the high gain, you got all this gritty stuff in the background. So let's see what we get now. So, well, it's still pretty gritty. Even with low gain and a 60-second image. I wonder why. It's so grainy. Let's see. It could be, well, I got the cooler on. It's about minus 21 degrees Celsius in there. Take a shorter image, 30 seconds. Let's see what we get there. 21 seconds left of this image. This is a pretty galaxy. I would have thought that we would have gotten a nicer image than that. Not as grainy. So let's see, 3 seconds. Oh, it's still really grainy. I guess it's got to be, stopped it. Guess we need to do this for a longer period of time. We'll take a long image. I'll let you know what we got. Take a look.
Keep going.
So this is the little sombrero. It's not tracking well. It's really grainy here. I really need to take a long exposure to get a nice image of this. I can blow it up a little bit for you so you can see it, but it does look nice. You got a dark lane. You got this really bright bulge. This would look really pretty with a stable long image, but I'm not getting that tonight. I got a lot of noise in this because I do need to take a longer image than I took, and we're not tracking well. You can see the stars kind of blurring out, but that'll conclude our adventures for this evening. Appreciate everybody taking the time to watch this. So